So welcome to the 2025 graduation celebration of the William E. Boeing Department of Aeronautics and Astronautics. My name is Christy Morganson. I am the chair of this great department. Graduates, today we celebrate you. Your dedication, your training, and your readiness to shape the future of aerospace. Your A&A degree represents years of rigorous study in one of engineering's most demanding fields, and you should be very proud of what you've achieved. You're graduating at an extraordinary moment. Right now, aerospace is rewriting the rules of what's possible. We're landing rockets back on Earth like something out of science fiction. We're preparing to return to the moon and venture to Mars. We're revolutionizing how we explore, connect, and protect our world through space. And here's what excites me most. You're not just witnesses to this transformation. You're about to become the architects of what comes next. Whether you're designing the aircraft that will make aviation cleaner and more efficient, developing the satellites that keep our world connected, or pushing the boundaries of space exploration, you have the knowledge and the passion to solve challenges that previous generations could only dream about. That's one reason why we're especially honored today to have our 2025 distinguished alumnus, Gary Lai, here with us today as our keynote speaker. Gary didn't just study aerospace here, he is living it. As a 1999 graduate, he started at Blue Origin as its 18th employee and worked his way to become the chief architect of New Shepard, the reusable launch vehicle that he himself had the opportunity to ride into space. I did ask him, he said he doesn't call himself an astronaut, but I think we could. So, it's your call. Talk about seeing your work come full circle. Gary embodies what it means to be boundless, turning classroom theories into vehicles that carry humans to the stars. Graduates, when you leave here today, you join a distinguished network of A&A alumni who are making their mark across the industry. The future of flight, whether that's 5 miles above Earth or 5 million miles beyond it, is in your hands. You will show the world what Huskies can do. Yeah. So before we hear from our distinguished speakers, let's celebrate some exceptional work from this year's graduating class. As you may know, the seniors worked very hard on their capstone projects. Capstone is our team-based program to develop solutions for industry, our student organizations, or in-house research led by faculty. Some of you might have watched our Capstone Film Fest, either in person or on YouTube. If you didn't, you can still get to it through our YouTube channel. Go to aa.washington.edu for that, and then follow the links. This past week, they presented their final design acceptance reviews, exploring the technical solutions of their projects. We would now like to recognize excellence in our capstone program, starting with the film festival. For these team awards, please stand up, just stay where you are, but stand up, when your team is called, or if your team is called. When? Okay, we'll take turns standing up. Everybody gets to stand up. The People's Choice Award for the Capstone Film Fest is the Aero KWT team. Please stand up. Yeah. Nice work. This team designed and built a low-fidelity aircraft model for testing in the Kirsten Wind Tunnel that delivers stability, control, and performance data within 10% of high-fidelity results while minimizing costs. Congratulations, Aero KWT team. The next award is the Best in Show Award for the Capstone Film Festival, which is the Vortex Lab. Please stand up. The team developed an active strake system that can be dynamically controlled during flight. Using wind tunnel testing, they evaluated how an innovative pneumatic system can adjust airflow over the wing to optimize lift and drag coefficients across cruise, takeoff, and landing conditions. Congratulations, Vortex Lab team. And now we have our 2 technical capstone team awards. The winner for innovation is the Boeing SSA Space Debris Monitoring Constellation. Please stand up. The Boeing team tackled a triple challenge, designing not just one CubeSat, but an entire constellation of CubeSats and prototyping excuse me, I can't even say it, prototyping a sensor system to detect space debris. They dove deep into constellation analysis using ANSYS STK, which, think about that, it's AA310 for those of you who took it, it's orbital mechanics, on steroids. At the same time, sorry, it occurred to me, like you all know what that is, but your parents and friends maybe don't, how things move in space. Simplify as far as I can there. They learned optics theory beyond our standard curriculum and built a working prototype sensor with detection algorithms. While the prototype revealed the real challenges of detecting space debris, their conceptual design work shows how to account for these challenges moving forward. Their final design merges both the practical prototype lessons and the theoretical constellation work, giving their industry sponsor a solid foundation for the mission. Congratulations, Boeing SSA team. And the capstone award for technical excellence is SARP Orbital Transfer Vehicle Thruster Prototype. And also, your launch yesterday was beautiful. Were any of you there, or did you come back from there? Or anybody who went to the launch? No. Okay. I'm sure you were watching. It was gorgeous. All right, the SARP team came in with RSO, so that's, thank you, oh my gosh, Registered Student Organization. So one of our student organizations that does design work. So they came in with that experience, but this year's students took it to the next level. They designed an industry-quality regenerative bipropellant rocket engine with professional-grade analysis, CAD, and manufacturing. They built a test stand that met industry standards and created test procedures rigorous enough for NASA, and more importantly, rigorous enough to earn UW approval for a hot fire test right here in the department. I think that's actually harder than NASA. Yeah. The engine fired successfully on the first try. Their industry mentor was literally biting his lips with emotion during the test. The team wrapped up with a data-driven acceptance review and conducted themselves with the highest engineering ethics throughout. They didn't just show a desire to build rockets, they learned and practiced all the processes that lead to aerospace success. Congratulations to the SARP capstone team. We will now shift to our Student Excellence Awards for Research and Service and award them to those selected who are graduating here today. So there are some that are not graduating, so we're just going to go with the ones who are here. So the Student Excellence Award for Master's Level Research goes to Chi-Chen Yao. Congratulations. So Chi-Chen's research combines cutting-edge experimental techniques with computer modeling to understand how high-performance polymers behave under stress. His work on nanofoam formation could lead to lighter, more heat-resistant materials for future aircraft and spacecraft, demonstrating exceptional skill for a master's student. Congratulations. Oh, come up and receive your certificate, please, actually. The Student Excellence Award for undergraduate level research goes to Dina Villasenor. Come on up. Dina's research explores how snakes achieve efficient movement despite having rigid bones and soft muscles. Her mathematical model revealed that snakes must actively control each body segment stiffness to move so elegantly. This research could lead to more adaptable robots for search and rescue operations and planetary exploration. All right, and the Student Excellence Award for Teaching goes to Thomas Key. Thomas was the teaching assistant for Junior Lab. Students appreciated Thomas's dedication to helping them truly understand the material rather than just providing quick answers. He would stay after lab sessions to clarify concepts and encourage independent problem solving while setting clear expectations. His approach fostered the skills students needed to succeed in challenging coursework. Okay. It is now my pleasure to recognize a faculty member for our Distinguished Faculty Award. Our graduating students submit nominations for the impact our faculty have had on the student experience and the community and their experience and the community, and for their commitment to high academic standards. This year's award goes to Professor Bob Breidenthal. Bob, please come forward. Students praise Professor Breidenthal for making learning genuinely enjoyable and engaging. They feel that his exceptional ability to teach with humor creates classroom atmospheres filled with curiosity. Students commented that his gentle approach instills the joy of learning without fear of failure, and his willingness to step in wherever needed demonstrates his dedication to student growth both inside and outside the classroom. Congratulations, Bob.
Thank you.
Okay, so now let's hear from two of our outstanding graduates. Jacob Sawyer and Kurt Kara, please join me on the stage. Okay, there's the two seats over there. All right, so I am proud to introduce our undergraduate speaker, Jacob Sawyer. Jacob has made quite an impact through his leadership in our Society for Advanced Rocket Propulsion and his research in our Space Lab, focusing on experimental spacecraft propulsion with Professor Justin Little. After graduation, Jacob will be joining Blue Origin as a structures and mechanisms engineer, taking his passion for space exploration from the classroom to industry.
Well, hello, everyone. So, I want to start. Thank you to all the family, friends, faculty, staff, and of course, graduates who could take the time to be here today. Now, I might be the first person ever to wax poetically about Kane Hall, but this place has something of a special spot in my heart. It was in this very room that I took my first college final, and looking back at the experience, I really remember just how overwhelming it all was. But after 12 more quarters of finals, the experience looks almost mundane in retrospect. I think for many of us, college has paradoxically felt as if it both passed in the blink of an eye while also dragging on for an eternity. And I think what that means is we remember life by the big consequential moments, but we often miss the little steps that happen in between. With that in mind, what I want to talk to you today about is persistence. And in that, I mean both definitions of the word. Both to continue in a course of action despite difficulty and opposition, but also the prolonged existence of something. To get here, every one of us has practiced persistence to an insane degree in both our professional and personal lives. In this crowd, there are graduates with kids, full-time jobs, clubs, research, sports, and everything in between. And I think it's incredibly impressive that they mustered up the willpower every week to attend an 8:30 lecture or spend an extra few hours studying for a final. While it doesn't always feel this way, our consistent efforts leave their own mark on the world. I think speeches like this often focus on how we will change things after graduation, but what really matters, and I think it really is criminally undersold, is how much of an impact we've already had. Many of you have taken your first steps in building hardware for airplanes, rockets, satellites, And I think the magic of holding an object of your own labor in hand is why many of us became engineers in the first place. And those of you who have worked in research labs have spent hours combing through data to create fascinating papers and posters that advance really the bleeding edge of engineering. And all of us who have taken the time to complete this degree have started our lifelong engineering community and have built friendships in the face of one of the most challenging undergraduate experiences out there. Regardless of what happens next, I think it's worth taking a moment to introspect on the magnitude of that achievement. What we have built in these 4 years will live on in physical form and in spirit as a monument that we tried to make our dreams a reality. Personally, I believe my greatest moment of persistence has come through my time on the Society for Advanced Rocket Propulsion, also known as SARP, which is a collegiate rocketry team here in the Aero department. I was not expecting the shout out before, by the way. During my 4 years here, I've completely fallen in love with this team and rocketry as a whole. And for my junior year, I had the pleasure of leading the team as project manager. And I have no shame in admitting this, but for my first few months, I screwed up a lot, either in missing paperwork or poor communication, or trying to understand the true black magic that is avionics. And there were plenty of moments during that time where I felt like I was ready to throw in the towel. But what kept me going was the enthusiasm and camaraderie from my teammates on SARP, as well as you all in this cohort. And let me tell you, I persisted for a year of long days, meetings, presentations, work sessions, testing, and untold hours of problem solving. And after many, many hours of trying to understand the labyrinth that is university policy, I think I now know more than anyone should ever have to know. And through the hard work of 130 other SARPers and myself, we were rewarded with our big moments. That year, SARP launched rockets 3 times and returned to international collegiate competition, while also becoming the first student team ever to fire a liquid bipropellant engine. Watching people finally get their win after dozens of sleepless nights, frustration, and sometimes disappointment is what made all the time I sank into SARP worth it. Both the joy I felt in those moments and the lessons that made me a better engineer are something I'll take with me for the rest of my life. One last thanks to everyone on SARP. It really has been the experience of a lifetime. So, I'll leave you all with 2 points. To the educators and staff, being a student has been getting harder every year. When you can, it means a world of difference to give a little grace and push a due date or let an extra undergrad into your lab. Lucky breaks like that are what kept us all pushing to the finish line. And then to my fellow students, I've been in awe of you every day, especially these last 2 years. I've had such a pleasure getting to know you all through the highs and lows of this degree. We're about to start careers where our day-to-day work will shape the world in real and sometimes dramatic ways. It is on all of us to look ahead and ask difficult questions about what creations we want to persist before putting pen to paper. Now, I have no doubt that all of our hard work from these 4 years will pay off. So, to more big moments, thank you.
Thank you, Jacob. It is now my pleasure to introduce the graduate student speaker, Kurt Kara. Kurt is receiving his Master's of Aerospace Engineering today. He brings a unique perspective shaped by his multicultural background and deep family roots in aerospace. Kurt follows his grandfather's footsteps into the industry and now works at Boeing, but his ambitions reach even higher. He's pursuing his ultimate goal of becoming an astronaut. Kurt believes engineering goes beyond technical knowledge, requiring curiosity and thoughtful problem solving to address real-world challenges.
Good evening, family, friends, and fellow graduates. It's an honor to stand here today as a part of this graduating class, a group of thinkers, builders, and problem solvers who spent the last couple of years knee-deep in formulas, research papers, simulations, late nights, and endless iterations of trial and error. Today is a big milestone. We've earned it. Like many of you, my journey into aerospace engineering didn't start in the lab or in the classroom. It started in the little things. For me, it was Lego bricks and puzzles as a kid, trying to understand how things fit together. I didn't know it at the time, but that curiosity would become the foundation for everything I do today. I was really lucky to have people in my life who saw that spark and encouraged it. My grandfather, Barry, was an aerospace engineer. He had a calm, methodical way of looking at the world. Never rushed, never flashy, just focused on getting things right. He talked to me about aircraft and design like it was the most normal thing in the world, but to me it was fascinating. I didn't just look up to him, I followed in his footsteps. Today, I stand before you wearing the very gown he wore to get his master's degree. I carry that legacy with pride, but I also try to make it my own. The last few years in this master's program tested all of us. The coursework was tough, the expectations were high, and there were times when the work felt endless, when the simulations failed, when the results just didn't make sense. But we learned that through that challenge came clarity. We didn't just understand how to be engineers. We learned how to solve problems, how to think critically and outside the box, how to stay calm when things don't go as planned. That mindset, more than anything, is what will carry us forward. Aerospace engineering is a field that demands a lot, but it also offers something rare, the chance to work on problems that matter. Whether it's designing a more efficient spacecraft, testing aircraft structures, or contributing to cutting-edge research, we're in a position to shape the future of travel, of exploration, of technology. That responsibility is real, and it's exciting. For me, the dream doesn't stop there. One of my long-term goals is to become an astronaut. I know how competitive that path is. I know the odds, but I know that the journey itself is worth it. Space represents the edge of what we know, the edge of what's possible. Being a part of that effort in any capacity is something that I will continue to work towards. I hope each of you has a goal like that, something that challenges you beyond what's comfortable. Not because we have to prove anything, but because we owe it to ourselves to find out what we're capable of. At the same time, I want to say this. Ambition doesn't always have to look like a rocket launch. Sometimes the most impactful work is the quiet kind, the careful design review, the thoughtful mentorship, developing the solution that no one else thought of. Great engineering isn't always glamorous, but it matters, and it lasts. So as we leave this program and step into the next chapter, my message is simple. Stay curious, stay focused, stay grounded. Keep asking questions, keep building, and most of all, keep learning. Aerospace engineering is a moving target. Technologies evolve, standards shift, new challenges appear. But what doesn't change is the mindset we've built here. The ability to approach complexity with discipline and purpose. To our professors, thank you for pushing us. To our families, thank you for your patience and support. To my classmates, thank you for the late night Discord calls, the group study sessions, and the shared feeling that yes, this is really hard, but we're all in it together. We've got the tools, we've got the training, and we've got the mindset. Let's put it all to good use. Congratulations, class of 2025. Let's go build something.
Thank you, Kurt, and congratulations. We now turn to honor our 2025 Distinguished Alumni Award winner and keynote speaker, Gary Lai. As I mentioned before, Gary received his bachelor's degree from A&A in 1999 and has spent the past 25 years pioneering the commercial space industry. He was Blue Origin's 18th employee and rose to become chief architect, leading development of the New Shepard reusable suborbital vehicle that transformed commercial spaceflight. Gary also chaired the design review board for the Blue Moon Lunar Lander program and played a key role in Blue Origin's work that earned the 2016 Collier Trophy, one of aviation's highest honors. His achievements have earned him multiple industry recognitions, including the RNASA Foundation's Stellar Award and the Museum of Flight's Pathfinder Award. In 2022, Gary experienced the ultimate validation of his engineering work when he traveled to space aboard New Shepard, the very vehicle he helped create. Today, as co-founder and chief technology officer of Interloon, Gary is pioneering sustainable methods for harvesting lunar resources to address Earth's resource challenges. In addition to his A&A degree, he holds a bachelor's degree in applied economics and business management from Cornell University. Gary, I am honored to give you the Distinguished Alumni Award for 2025. Okay, so we are very excited to hear your words of wisdom to this amazing graduating class, so the stage is yours.
Thank you, Christy. Good afternoon, UW Aero eminent graduates, families, friends, faculty, and staff. It's a deep honor and pleasure to speak to you. So 26 years ago, I was where you're sitting today, a diploma in hand, with very big dreams, but probably bigger anxieties. I think the reason the department has this tradition to invite alumnus of the department to speak to you is to provide some advice and guidance on the path that you're about to embark on from the perspective of someone who's walked it. And so that's what I intend to do, to really share 5 bits of wisdom, I hope they're wise, that I wish my future self had told me 26 years ago. The first thing I want to tell you, and this is as much to your families as to you, is congratulations. In selecting a degree in aerospace engineering, you have made the right choice. So validate that, not just for your financial future, because obviously engineers are quite well paid and highly employable, but more importantly for the impact that you can have on the world. There are many careers you might have chosen with your talents, but in my humble opinion, in the course of human history, it is the scientist and the applied scientist, the engineer, that have made the most profound impact on the quality of human life. And that is because the fundamental knowledge and practical skills that you have learned in this degree have given you a superpower, the power to invent the future, and in your case, to see it fly. So that is my first message to you. Congratulations, because you now have superpowers. The second thing I want to tell you is you need to use those superpowers in a responsible way. With great power comes great responsibility. And more specifically, in a way that aligns with your passions and values. So for each of you, that path will be different. Some of you will be inspired to work in our national defense, some of you to push the boundaries of space exploration, or perhaps in sustainable aviation. But whatever it is, I urge you not to settle for anything less than work that you are passionate about. You are too good for that. Maybe you don't know what that is yet, and that is okay, you have time, but you will know it when you find it, and over time it will find you. Let me share a little bit about my own journey of discovery. I was lucky enough that when I graduated 26 years ago, I had found that calling, that passion, my life's work, which still drives me today, and that is the conviction that the existential problem of humanity over the coming millennia will be that Earth is finite, that we are using its resources faster than can be replenished, and that the resources of outer space, even in just our solar system, are effectively infinite. So if in our current trajectory, we have 2 paths that society can choose. We can choose to stay in that finite closed system, and that will lead eventually to conservation, mass conservation, population decline, and stasis. Or the other path is that we can learn the techniques to utilize the infinite resources of outer space to grow human civilization. And so I was convinced that the very first step in doing that was we needed to dramatically lower the cost and improve the safety of getting to space until space travel became as commonplace as air travel is today. And that required perfecting the techniques of reusable rocketry. And so I devoted 2 decades of my career to that purpose, eventually leading the team that designed, built, and launched New Shepard. And by the way, that team had many UW graduates on it. 9 years ago, only 9 years ago, New Shepard became the first rocket to be recovered and reused multiple times. And in that short time since, it has become absolutely commonplace, not just by Blue Origin, but even more dramatically by SpaceX. Our purpose in building New Shepard has never been about space tourism. Our purpose in building New Shepard was to serve as a platform to perfect the techniques of reusable rocketry. And now it has done that 32 times. When I started my career 26 years ago, it cost about $10,000 a pound to launch something into orbit. And 1 in 50 people that ever launched to space died in the process. Today, that has gone down by a factor of 10, and it is so safe and accessible that we can have sometimes the controversial conversation about celebrities flying in space, or even people like me, without commenting on really the true headline from an engineering standpoint, that we are not even talking about how much of a technical marvel it is, because it is now so commonplace. In the next decades, the cost of access to space will drop by another factor of 10, and then in the coming centuries by 100 or more, and it will be so commonplace it will be no longer news. And people will go into space by the hundreds, and then thousands, and then millions, to not only to work, but to live. But this is where it all started. And so my journey continues. In this current chapter, we have reached the tipping point of low-cost launch where it is realistic for private industry, companies like Interloon, to harvest resources of natural space to improve life on Earth. And we're doing that first at our Earth's nearest neighbor, the moon, the 8th continent, because it has adequate resources to support a large industrial civilization. So that is my journey. Your passions and values will take you to other places. But the most important thing is that you work on that thing that you are passionate about and settle for nothing less. My third message is to be bold. Over the course of your life, you're going to face this choice many times. Do I choose the safe and comfortable path, or do I choose the path that is high risk but high reward? And maybe you will make that occasionally, that choice of the safe and comfortable path. And you will probably live a comfortable life, and you will probably do nothing remarkable. So my advice to you, if you actually want to have a true impact on the world and do remarkable things, is to be bold. Choose the path of high risk and high reward. And people are going to shake their heads at you. They're going to call you crazy. Not 1 in 10 or maybe 1 in 100 people take this path. And it will be hard, and you will fail many times. But in the end, the true change agents of history have been the risk takers, the mavericks, and the downright weird people that don't quite fit in to conventional society. If you feel like one of those people, you are in good company. So do not hide in conformity and comfort. In my own life, I have often faced this decision. And usually when I see the safe and comfortable glide path, I end up swerving hard to the left into turbulence. I've worked at 4 companies in my career. All of them were startups when I started. And I'm not encouraging you to only work for startups, because even established companies can do bold things. The key is to seek the environments that take risk and for high reward and encourage experimentation. Only those places, only those projects will do remarkable things. So again, my third message is to be bold. My fourth message to you is never stop learning. So you are about to get your diplomas, the badges of your intellectual superpowers, but this really should just be the start of your educational journey. As the saying goes, the more you learn, the more you realize how little you know. You will be enriched not only by the depth of your knowledge in engineering, but by the breadth of your knowledge in everything. By everything, I mean everything. History, languages, biology, social sciences, the arts, the list goes on. If you ever stop learning or restrict your learning to just getting deeper and deeper in a narrow field, not only will your life probably become quite dull, but as a knowledge worker in our day and age, eventually you run the risk that artificial intelligence is going to render your skills obsolete. AI has already gotten incredibly good at doing rote things, predictable things quite well. But I believe in the long run, it will be a very, very long time before AI can replace human beings with broad educational backgrounds that can synthesize knowledge across multiple fields. And those are the kinds of problems, the multidisciplinary complex problems, that are the key challenges of our future. The very best investment will be able to make in your entire life is not in stocks, it's not in bonds, it's not in crypto. It is in yourself. It is in your education and experiences. And so I don't necessarily mean getting advanced degrees. I mean, it could just be simple as when you don't understand something that a colleague is saying, ask them to explain it to you. It could mean reading books. It could mean traveling the world, seeing other cultures, meeting new people. The time to do that is now. In your youth, the more time you have the earlier you get that education, the earlier you get those learnings, the longer you have for those educational dividends to grow and improve your life. Again, reflecting on my own experience as a system architect of space systems, I had advanced to positions not because I was ever particularly good at any one single subject. In fact, I would not ask myself to do anybody's job on the team, and they shouldn't ask me either, but because I knew something about many subjects, and I could translate between those single discipline teams and see the big picture and understand the trade-offs and make the decisions that transcended those teams. So again, my fourth message to you is this: invest in yourself, never stop learning. And finally, my fifth message, and probably the most important one, is that it's not about our technology that we're developing, it's about the people. The most important thing that you will do in your lives is not to develop a product or conduct research. It is to improve the lives of others and the community. When I reflect on my own career, rather than all the technical milestones that we have hit or that I have contributed to, that have given me the most joy, I reflect instead on the people that helped me along the way and the ones that I have helped. And that includes my time at the University of Washington, for sure. In fact, there are faculty members that I took courses with here and I deeply appreciate, including Bob Bridenthal. Another example is the former chair of the department, Professor Adam Bruckner, who is not just a great teacher, but he got me my first job in aerospace. It was the first and last job that I ever interviewed for. Through that one job and the network that I built, it led to the group of people that sought me out for those other future opportunities. Our work in this industry is much, much more about building the teams that build the flying machines than it is about building the flying machines. Seek out and surround yourself with the very best people. Learn to communicate with them and collaborate, network, help them, and they will help you. So in that spirit of helping community and giving back to the department, this department, which has meant so much to me over the years, my wife and I have decided to give back and establish the Gary Lai and Natalia Yudkowsky Faculty Fellowship in Aeronautics and Astronautics. We intend this gift to support a faculty member in the department who will advance the frontiers of space exploration. So to summarize, these are the 5 pieces of advice I have for you today. You have superpowers, number 1. Number 2, settle for nothing less than to use those superpowers to pursue your passions. Number 3, be bold. Number 4, invest in yourself and never stop learning. And number 5, it is about the people. I can't wait to see the amazing things that the UWAA class of 2025 will do in the future. Thank you and congratulations again.
All right, thank you, Gary. That was exactly the inspiration our graduates needed to hear as they begin their careers. Now it is time to honor the students of the class of 2025. We will call each graduate up for their diploma holder. We have an A&A certificate in here, but you can swap it out for your actual UW diploma when you receive that. They don't give them to us to give to you, sorry. All right, so first we start with one of our most cherished traditions, honoring our doctoral graduates. We begin with those students here today who have earned the Doctor of Philosophy with a few words from their faculty advisors and the ceremonial hooding. Okay. So getting them all queued up here. All right, and I apologize. I'm reading my instructions here. I'm not sure I fully understood. I'm supposed to stay here? Okay, great. Okay, Bart Boom, please come up. Bart would like to thank all his awesome collaborators and lab mates. Without them, this body of work would not have been possible. Bart's dissertation is Harnessing Nature's Structural Vibrations. His advisor is Professor Ed Haptor. Ed? Yeah, you come over here and say a few words. Yeah, over here. Microphone. Microphone.
Okay, it's my first time, obviously. Okay, so some of you told me that you're looking forward to hear me saying something outrageous. So I'm not going to disappoint. This highly medicated ADHD professor thought I was outrageous until I met Bart and Tice, since we know we're graduating both of them, or hooding both of them. And today we celebrate their accomplishment because they are the most outrageous scientists, researchers that you'll ever meet. And this is why. I'm going to start with Bart. So I met Bart in the Netherlands, and the Dutch are known for being laid back, and they have a saying called, what they say is, be normal. Normal is crazy enough. There is nothing normal about Bart. First, it didn't take much to convince him to come to the States because, well, the universities there are so powerful. I convinced him that UW is crazy enough for his ideas. And I suggested that he would build an aquatic aerial transformer robot capable of impacting the water surface at a velocity of 70 miles per hour. So he took inspiration from the gannet. That's a bird that does that. And what he uncovered that these birds have slender structure, segmented, curved, and they don't buckle. It completely violates everything that we learn in engineering. You don't design your structures like that. Fascinated by this problem, Bart, a couple of years later, got bored of this problem. It wasn't outrageous enough for him. So he decided to, in addition to the gannet, it would be really interesting to study the stingrays because each wing on the stingray has more than 100 bones. So he started to look at the vibration of these creatures, and he came to uncovered that they have specific geometries, shapes, connections that allow them to self-propel themselves in such an efficient way, perform complex dynamic functions with far less muscles than human or other animals. And in pursuing this, he started his own operation with my colleague Adam Summers. Would you stand up, please? Just stand up, stand up. So Bart created his own empire with his minions, and working with Adam Summers, created international collaborations. And he really started to develop the theories that would lead to these really beautiful dynamics coming out of really simple idea of how these geometries are connected, how the shapes are designed specifically to perform certain functions. While his name is pronounced boom, which means tree in Dutch, you will always be Dr. Boom to me, because your ideas, your science, your beautiful mind are booms of outrageous discoveries. Congratulations, Barks.
Keep the chair there. It is a challenge, actually. Congratulations. Okay, next, John Corey, please come up. John would like to thank his family and friends, as well as countless members of the department, for their support over the last decade. His dissertation is Characterization of Gas Dynamic Effects in Baffled Tube RAM Accelerators. His advisor is Professor Carl Nolan. Carl?
John had first come to my attention as a senior in capstone design and space design in 2019. He went on to do his master's degree, first in Earth and Space Sciences with Professor Wingley, and he finished up with Professor Yuri Shumlak doing wireless power transmission. He chose to join us in the RAM Accelerator and change his field of research to that of ramjets and chemical propulsion. He quickly learned the gas dynamics and internal ballistics associated with the RAM Accelerator, which is a device, an in-tube ramjet that is capable of propelling payloads into Earth's orbit. He took his EM skills and analyzed the distortion of magnetic fields being propagated through steel tubes, and led to our ability to more accurately track the trajectory of projectiles in tubes. He, on his own, developed a filtering algorithm that filtered high-frequency pressure data, that took out noise, that enabled us to see the actual signal and better interpret the results we were getting. And he greatly enhanced the uniformity of the bookkeeping, which is very important in research, and the further data processing. In John's experiments, in his experience in the lab, he recognized that understanding the interactions of a projectile as it passes through a washer-like baffle was critical to improving the operation of the baffle tube RAM Accelerator. And in that, so to further that goal, he designed a transparent tube section that had an outer curvature such that that would collimate or take a collimated beam, refract it into a circular observation chamber, such that it would remain collimated in the cylinder, and then on the back side of the tube, leave and refract back to a collimated beam, so that it can be used with shadowgraph and Schlerin photography, high-speed photography. And experiments with this apparatus are in progress. John has also been served for quite a while with the NASA Space Grant. And he's more recently been the master TA for the A&A department, helping the other graduate TAs. And he actually currently is serving on the Student Technology Fund Committee. This is the committee that allocates funds from the student fees to purchase big ticket items that are then accessible to anyone in the student body. And I'll say, and finally, in addition to the service and what he has provided for both the department and the university, I could say that it has been a great pleasure to work with John, and he's been a wonderful collaborator. And we're going to miss him in the lab, but we are looking forward to hearing of his future accomplishments from what we are sure is going to be an illustrious career.
Aditya Deal, please come up. Aditya would like to thank his friends and family for their utmost support. His dissertation is Robust Control Methods for Systems with Modeling and Estimation Uncertainties. His advisor is Professor Mehran Misbahi.
Good evening. So Aditya literally means the sun, and he has been the sun of our lab for the past number of years. He came from mechanical engineering with great enthusiasm and energy, interested in implementing new control algorithms and developing new hardware platforms for ground robots and drones. In many ways, I would say the sun has been one of the most versatile PhD students over the years that I've known, diving into whatever comes his way in terms of research topics and initiatives. For example, when there was an opportunity to collaborate with a group of colleagues at JPL on using machine learning-based perception in the spacecraft feedback loop for the purpose of tracking uncollaborative space objects, Aditya was quick not to only develop the right theoretical and algorithmic framework, but also moved on to develop the entire stack for the training of the neural networks using a game design engine, using photorealistic images in low Earth orbit. He then proceeded to create the right interface with the spacecraft dynamics and control. And all of these non-trivial steps was done in such a nice professional way that the JPL colleagues started using his work internally to develop the algorithms further. And again, a couple years later, when I started collaborating with a bunch of neuroscientists on UW campus on thinking about dynamics and control problems for experimental setup that they were looking at, Aditya once again stepped in, brought his mastery of robotics, aerospace control design, hardware and software expertise, and his enthusiasm to significantly contribute to the project to the extent that my colleagues start asking me if they can hire him and steal him from my lab. I said no. So over the years, he has been a mentor to a number of undergraduate and graduate students in our group and the department. I'm glad he's going to stay a little bit longer at UW so I can interact with him. I'm already looking forward to continue collaborating with him after graduation. Congrats, Aditya, the son. You know you will continue to be an integral part of the RAIN Lab no matter what. Thank you.
Next is Kazuya Echigo. Please come on up. Kazuya would like to thank his family for their unwavering support in having started his career at JPL, is pursuing his dream of one day traveling to Mars. His dissertation is From Theory Towards Flight, Convex Optimization-Based Approaches for Non-Convex, Stochastic, and Realistic Aerospace Missions. His advisor is Professor Becek Achikmejek.
Congratulations, Kazu. I met Kazu several years back before COVID. The first time he showed up in my office, he had 2 big luggages. He was traveling around US trying to find a graduate school a program that he could conduct his research. He came right before COVID, so it was a hard time. He was coming from Japan. And if I could find one word to explain what he demonstrated during his PhD, it is perseverance. His start wasn't smooth. Again, COVID was the major issue. He had some setbacks, personal setbacks. Despite that, Kazu didn't give up. He pushed through. Not only he pushed through, in the second half of his PhD, his research blossomed. He produced at one of the highest levels I have seen in a short time. He collaborated with my colleagues at JPL for the last 2 years. He produced amazing results. He first of all identified good problems that are applicable to space engineering, space robotics. He developed optimization-based techniques that render them solvable. These are hard problems and real-world applicable problems. And then he wrote about his solutions. He published a lot in the last 2 years, many conference and journal papers. Now he's a postdoctoral researcher at Caltech, and I'm sure he will continue being successful because he doesn't give up. He keeps on hitting, and he literally succeeded much better than I expected, especially considering the start, which was at a really bad time. I really am telling this out from deep from my heart. Congratulations, and I'm really proud of you, because this was an amazing achievement. Thank you.
Next is Kimberly Ann Hinson. Please come on up. Wait, where are her people? I'm asking this for a reason. I cannot find you. Wave your hands in the air, Brian and team. There you are. Okay, great, thank you. Okay, so the reason I'm saying that, okay, I'm supposed to read this first. Okay, sorry. Kimber would like to thank Honor and Ira for their creativity, kindness, and hugs. Her dissertation is Aerospace Applications of Noise Covariance Identification with Autocovariance Least Squares. So I'm her advisor. That's why I was asking where her people are. Let me do your diploma first. Okay, so Kimber, I actually met Kimber when her husband was one of my PhD students back a few years ago. So it's been a whole bunch with the family. I guess Ira and Honor are still a little bit young, but we'll work on them next. Kimber has done her PhD while also being a full-time engineer at Boeing. She manages a large team there, and as noted here, she has a couple of young kids. So she's done all of that while pursuing her research, which I have to tell you, it's hard enough to do a PhD, but navigating the rest of that is quite a big deal. So Kimber's ability to navigate time and space is amazing. Because really, I do think there was some spatial manipulation there. So her dissertation focuses on how better to define and assess noise in aerospace systems. So what that means is, so all of the systems we work with, and in her case primarily aircraft, have things that come at them like wind gusts. You probably know this if you've been flying on airplanes. The weight shifts around when they're flying. in unfortunate situations, like a bird might hit the windshield or something. There's noise in the sensors of the GPS system. All of the sensors throughout the aircraft, they've got some, they fluctuate a little bit with temperature and a variety of conditions. And so one of the things that we do as controls engineers is we try to characterize that and then compensate for it. And the better we can know that information about the noise, the better job we can do with compensating for the issues and make more efficient and effective aircraft. So things like how well it feels to ride in the airplane. So Kimber's been working on that for a number of years, and it's not only in a theoretical setting, but she's been applying her work to aircraft at Boeing. I can't actually see all that information myself because I'm not a Boeing engineer, but some of the work is published in the open literature. The rest of it is being applied at Boeing. I think it's also good to say you are my 10th PhD student, so you're a nice round number. I'm very proud of you for finishing up, and all my best. Congratulations. Okay, next up is Andrew Jansen. Andrew would like to thank his advisors, friends, and family for their support during his pursuit of a PhD. His dissertation is 3D particle tracking velocimetry of the convective structure in transient evaporating liquid films. His advisors are Professors Jim Hermanson and Donna DeBerry. Professor Hermanson will be doing the honors. Come on up, Jim.
Okay, this is a pleasure. I have a lot of notes because there's a lot here because Andrew's done a lot. He first came to the department with the Dean's Fellowship, which is awarded to a top incoming student, and he's definitely lived up to that. His PhD research has been on evaporating thin films. It's a problem of relevance in industry with aerospace applications. How do you reject the heat? How do you get the patterns? What's going on inside these films? It's an important problem. And these very thin films, they change when they experience evaporation. There are changes in structure, there are changes in the heat rejection, all in a very complicated way. So what Andrew has done is he's developed an experiment to look at the detailed fluid motion inside these thin films. Films that might be the thickness of half of the diameter of a number 2 lead pencil. So down on the millimeter scale, to go in and take these measurements of the fluid motion inside the film. Much is known about how they behave looking down at them, but inside, that's entirely new knowledge. It's not easy. The films are thin. They take a lot of complicated diagnostics. Andrew has done that, and he's developed a unique particle tracking technique for monitoring the fluid motion inside these films. It's been done in combination with the essential mentorship of Professor Donna DeBerry. Please rise. And a recognized expert in advanced diagnostics of complicated fluid flows, and it's made all the difference in this work. So it's good science, what has come out. Motion within these films has not been revealed in detail like this by anyone. It's even better science because Andrew has found unusual things. When you see something unexpected in the fluid motion, that makes the problem even richer. So it's truly that original contribution to science that's the hallmark of a PhD graduate. Okay, beyond that, we're extending the work into an experiment to be flown on board the International Space Station. We've gotten NASA interest in this. The theme is always the same. You fly it in space, you take away the effect of gravity, and so there's no buoyancy, so all kinds of weak mechanisms start to emerge. That's why the interest is it's very difficult to form a flat film in microgravity. The fluid wants to grow and climb everywhere. Andrew's come up with innovative schemes for securing the film and maintaining its flatness, developing the hardware, working with our Space Tango industry partner to get this to work, and hopefully we'll be flying that as well in the coming year. So all of that is a testament to Andrew's excellent research, work as a scientist, as an engineer, superb attention to detail, understanding of the fluid physics, and extraordinary persistence in making everything happen. On top of that, he's an enthusiastic, excellent coworker, and I have no doubt he'll do well in his career. On top of that, he has a great sense of humor, and we managed to work well together even though one of us is an avid Dodgers fan and the other one is an avid New York Yankees fan. We got through all that. So thank you, Andrew, for all the great work. It's been a pleasure and honor to work with Professor DeBerry and me to collaborate with you on this innovative research. So I congratulate you, and I heartily welcome you into the community of scholars.
Next is Amirul Akil bin Kairi. Please come on up. Akil is grateful for family and friends here in Seattle, at home in Malaysia, and in between. This accomplishment bears their names as well as his. His dissertation is Plasma Electrode Interactions on the ZAP HD Flow Z-Pinch device. His professor is Professor Yuri Shimlock. However, Professor Shimlock could not be here this evening, so Professor Carl Nolan will be delivering his remarks. Carl?
Again, on behalf of Yuri Shumlak, I'm speaking here for Akil. Akil has come to Akil too had served in the RAM Accelerator Lab as a sophomore, junior, and he too is in a space design capstone course with me. And then he went on and did his graduate work with Professor Shumlak. And these are Professor Shumlak's words, and I'd like to get them as he wrote them. Keel's first approached Shumlak during his junior year in our department. His interest in space propulsion and fusion energy and his desire to tackle hard problems motivated him to join my research group, which studies the sheared flow stabilized Z-pinch plasma concept. And motivated he was. His academic strengths translated to productivity in research and an ability to ask the right questions and know how to find the answers. As Keel continued into graduate school pursuing his PhD, he was drawn to the most challenging aspect, the plasma electrode interface, where the highest temperatures in the solar system came in contact with room temperature solids. Akil pointed to that part of the experiment and said, there, that is what I want to understand. I want to understand what happens there. Akil's PhD research involves custom building a two-color pyrometer to measure the electrode surface temperature and combining those measurements with multi-point spectroscopic analysis to ascertain the surface erosion rate and the impurity migration into the plasma. He is corroborating his understanding using ex situ microscopic assays and using sophisticated scanning electron microscopy and X-ray spectroscopy. XPS, if that helps you. To explore the electrode coupons. His research has the potential to design self-healing electrodes that will enable long-duration operation in a fusion energy core or a deep space thruster capable of rapid missions to the outer solar system. In addition to his invaluable scientific contributions, Akil has become the lab leader. He organizes all lab activities and supports researchers at all stages, from incoming undergraduates to senior graduate students. He is a trusted resource for all the group members, including his advisor. Though a few T's still await their cross and some I's their dot, the real work, the scientific contributions, the personal growth, the lasting relationships is already complete. When the final chapter is written, he'll leave behind a legacy and a gap we'll deeply feel.
And our last PhD recipient for this year, Tice Massmeyer. Please come on up. Tice would like to thank his friends, family, and everyone in the Illimited Lab for always believing in him and giving him the motivation to keep going. His dissertation is The Signaling Properties of Spider Webs. His advisor is Professor Ed Habtor. Come back up for Tice, Ed.
We just talked about Bart, and we call him in the lab Aquaman for the type of research he's doing. Tice, we call him Spider-Man, and this is why. So Tice is another outrageous scientist. It was difficult to recruit him, to bring him here to the US. I met him in the Netherlands, another Dutchman. He really wanted to come here to work on difficult problems, and he needed to be convinced that the problems that he would be working on would be outrageous. What I did, I gave him the spider web to study and to look at just single fiber and the spider web and look at the signaling properties, how the vibration transmitted into this fiber. There are a lot of complexity in that fiber. So he spent a few weeks on it, came back. Not outrageous enough, he said. He wanted a problem to keep him up late at night. He decided to study the entire web architecture. And his research not only kept me late at night, it kept his dad late at night. Where's your dad? Stand up. So you and I were completely wrong, underestimated the power of his mind, because what Tice uncovered that there are some irregularities in the architecture of the web, that it leverages the geometries of the web so it can sense the prey when it hits the web. It can identify its location without any sensors on the web. The only sensors are in the legs of the spider. The web also works as mechanical filters as well too. So he called this, and others did too as well, biologists called it extended cognition, but they didn't really prove how it works. And this is the issue with biologists. They observe, they publish, and make things up. But engineers figure out the mysteries, the physics behind these extended cognitions, behind these phenomena. Not only did he uncover these remarkable geometric properties that enable the spider to sense, he developed a new imaging technique to capture the complex dynamic of the spider web because the fibers are really thin, so you can't put a sensor on them to see where they're going. So he used optical techniques using a single camera that gives you the entire dynamics of the web. And he went further and extended this knowledge to applications with social impact, where he transition this technology or this knowledge to develop splinters and casts for physical therapy and for treatment if you have arthritis or carpal tunnel. And this is how we roll at the University of Washington, the Aeronautic and Astronautic Department. Young minds like you and Tice and old minds over there, applying their outrageous science and engineering to incubate outrageous solutions, to break boundaries, to make the impossible possible. Tice, Spider-Man, congratulations.
All right, congratulations to our 2025 PhDs. They clearly got the memo already, so we're going to do a photo with the 8 of you up here. Okay, and now I will invite Professor Eric Herlin to come take the microphone to announce the rest of our graduates.
Hello, everyone. Students, we would like you to stand one row at a time, and in the aisle, come up to the stage on my right, just like you saw the PhDs do. We'll wait to call names until everyone's lined up. Come up when your name's called, hand me your card, and walk across the stage to get your certificate from Professor Morganson. Please pause for a photo on stage after receiving your certificate. We'll read a name and statement for each student. You can applaud after the statement. All right, we will start with the Masters of Science. Ayaz Ahmed. Come on! I would like to thank my parents and sisters. Nimit Berry. Nimit would like to express his sincere gratitude to his thesis advisor, Dr. Marco Salviato, for his exceptional mentorship, guidance, and unwavering support. Justin Chang. Life is the most complex optimization problem. All the objectives are in conflict with countless constraints. I hope I can figure it out before the only and unavoidable terminal condition is reached. Jackson Clevenger.
Jackson would like to thank his family, whose support and encouragement kept him going during the most difficult parts of his degree. QT Demir Ali. QT Demir Ali is grateful for the unwavering support of his family and mentors and looks forward to making a meaningful impact in his field. Harry Fury Soper. Harry would like to thank his family for their support and his undergrad capstone students for keeping work exciting. Akshay Gupta. Akshay would like to thank his parents for their endless support, his advisors for their guidance, and the Navier-Stokes equations for keeping things turbulent but meaningful throughout the journey. Rohan Hendry. Rohan would like to thank his mom and dad for giving him the chance to come here and learn new things and grow through every experience along the way. Shavi Kashyap. Shavi Kashyap is grateful to her family, friends, and mentors for steering her through the master's journey, and to Coffee for acting as her unofficial co-advisor. Thomas Key. Thomas is thankful for his colleagues and friends for their invaluable support. Amji Kim. Amji survived orbital calculations, caffeine overdoses, and coding chaos, but most importantly, she found joy, purpose, and incredible people along the way. Paul Medina. I would like to express my sincere gratitude to my advisor, Dr. Owen Williams, classmates in the lab, and my friends and family for supporting me throughout my time at UW. Janam Chaite Mehta. Janam is proud to celebrate this milestone and extends heartfelt appreciation to everyone who has helped make it possible. Lucio Murillo. Lucio is grateful for his family, friends, lab mates, and advisor for supporting him through his academic journey. Shubha Murthy. Shubha would like to thank Professor Hermanson, Professor Breidenthal, Goldie, her friends, family, and chicken biryani. Because this degree was layered, spiced, and occasionally burnt at the bottom, but always worth the wait. Jack Ninos. Jack would like to thank Dr. Owen Williams, his family, and Abigail for helping him on this journey and for their unwavering support. Juanita Osorio Tovar. Juanita would like to thank the people around her each day for inspiring her to grow, give her all, and be better. Raj Pandya. Raj would like to thank his parents, the professors, and his friends for their support during the degree. Teja Nagavardhan Pidi. Teja Nagavardhan Pidi has discovered that it's not the destination but the hearts beside you that make the journey unforgettable. Alessandro Pulimeno. Alessandro would like to thank his family and Denise for their endless support and Professor Williams, who helped them find a way even when it appeared there was none. Xavier Yogita Sharda. With heartfelt gratitude, Xavier credits his family for turning his dream into reality. Mitsuki Shimomura. Blessed are those who are persecuted because of righteousness, for theirs is the kingdom of heaven. Hannah Joy Shipman. Hannah has learned that she has high tolerance for very steep learning curves and wishes to thank her fellow students and professors for modeling curiosity in science, joy in collaboration, and a love for silly card games. Alicia Thakari. I'd like to thank my parents, Saili and Sangram Thakari, for supporting me throughout my journey. Priyanshu Singh. Priyanshu Singh is thankful for the challenges that shaped him, the mentors who believed in him, and the friendships that carried him through, and the unwavering support of his family. He has learned that true growth comes from persistence, purpose, and staying the course, even when the path ahead is uncertain. Ashok Vamparala. Ashok would like to thank his father, mother, and his thesis advisor for the teachings, support, and guidance they provided him throughout this program. Chai Chen Yao. Sam has learned structures in aerospace engineering, ensuring that while dreams may take flight, the wings won't snap off. Niha Rajan Yelve. Niha Yelve is excited for what's next and thankful for everyone who has helped her get here. Jason Shen Kunju. Jason would like to thank everyone who made his time at UW extraordinary, and he is excited for the adventure ahead. We will now recognize students receiving a Bachelor of Science in Aeronautical and Astronautical Engineering. Aya try this again. Okay. Aya Abushimas. Aya would like to thank her parents for their endless support and sacrifice, and dedicates this moment for the unyielding spirit of people of Palestine. Mazan Al-Harash. Mazan would like to thank his mom, dad, brother, and family in Syria for their support. Christian Cummings Ball. Christian will always appreciate the afternoon beauty of UW's campus. Russell Crofton. Russell is grateful to everyone who supported and mentored him during the ME program and looks forward to contributing to the advancements of aerospace engineering. Leela Jessica Noriko Culbertson. Leela Jessica will continue her role in commercial space transportation as a systems safety engineer. Elias Elmore. Elias would like to thank their family, friends, and mentors for their unwavering support and encouragement throughout this journey. Benjamin Gove. Benjamin would like to thank Quinn, Kathleen, and Steve for their support throughout the program. Rudy Jacobson. Rudy would not be here without the love and support of his family. Connor Johnson. Connor would like to first extend his deepest gratitude to all of his professors, teaching assistants, and advisors for helping him throughout his course. Second, he would like to thank his parents for the love and encouragement and instilling the values needed to complete this degree. And to his incredible wife, Connor would like to thank her for all the love and support, carrying the workload around the house, coordinating trips, and taking care of their beloved dog when he couldn't. I'm going to start charging by the word. Kurt Kara. Kurt Carr would like to thank his fiancée, Marina, for support throughout this degree program. Al Lacey. Al Lacey would like to thank his wife, Becky, for helping him survive grad school. Edward Mao. Edward would like to thank his mom for encouraging him to pursue a master's. Zachary Ryland Pablo. Zachary would like to thank his family and his youth basketball program, North Sound Premier. Win Pham. Win would like to give the best appreciation to his Washington and Houston family for their continuous food support and encouragement. Thanks all professors and TAs for sharing amazing knowledge, as well as classmates for learning and growing together. Eric Giancarlo Rios. Eric would like to thank his family for all the sacrifices they have made to allow him to complete this achievement, together through hardship, together through success. James William Schwartz. James is grateful to all the family, friends, faculty, and others who have helped guide him and support him on this road from high school dropout to attaining the level of education we celebrate today. Che Philip Weaver. Che is reminded that nothing worth achieving is ever done alone. He is grateful to his family for their unwavering support and to his fiancée Zoe for being the sole reason the frozen pizza industry is not currently a $1 trillion enterprise. Nathan Young. Nathan would like to thank his friends and family for all their support. And now for the Bachelor's of Science in Aerospace Engineering, Keon Agbarpour. Keon Agbarpour would like to thank his friends and family for all their love and support. Alexander Eric Alla. Alex would like to thank his family, Eric, Yumi, and Sakura Alla, and many friends for supporting him through these 4 eventful years. Bryn Amon. Bryn spent most of her free time in college hanging out with her dogs and being the worst player on her intramural sports team. Travis Anderson. I'd like to thank my parents who have made graduating possible for me and my friends who have made graduating worth it. Liam Baker. Liam would like to thank his mother for her continuous support. Xavier Beach. Xavier would like to thank his family and friends for all their support. Austin Bergeron. Austin is grateful for all the guidance and support that made this moment possible. Sabrina Briones. Sabrina would like to thank her mom, dad, and sisters, Valeria and Camilla, for always supporting and encouraging her. Kai Bristol. Kai would like to thank his parents for their unwavering support throughout his academic journey. Hugh Carberry. Hugh would like to thank his family for the support through school. Natalie Coates. Natalie thanks her family and friends for the love and support that helped her reach this milestone. Audrey Davies. Audrey feels immense gratitude toward her family for their support, Sarah for helping her in her classes, Jesse for his love and encouragement, and Nick, who she misses every day and knows would be so proud of her. Emma Dixon. Emma would like to thank her parents for their constant support and her students for inspiring her every day. Karsten Fetter. Karsten would like to thank his parents for their continued support throughout his educational career. Ryan Xavier Fidelis. Ryan would like to thank the Department and College of Engineering for the opportunities they provided, particularly the Design Build Fly program, which has been the highlight of my journeys thus far. Claire Fisher. Claire is excited to return to UW next year, pursuing a Master's of Science in Aeronautics and Astronautics. Go Aerodynamics. Francisco Flores Martinez. Francisco thanks his family and friends for supporting him throughout college and looks forward to returning next year. Vanessa Franco Lopez. Vanessa's graduation was made possible by study sessions with friends, TA office hours, and viewers like you. Thank you. Jasper Geldenblot. Jasper would like to thank his parents, brother, and grandparents for their unwavering support throughout the last 4 years. Zachary C. Gutfeld. Zach would like to thank his family and friends for their endless support. Catherine Gatormson. Catherine would like to thank her parents for their unwavering support and her siblings for being her biggest cheerleaders. Sarah Hines. Sarah would like to thank her parent, Kimberly Hines, for her endless unconditional love and support, and her cats for their tireless help with homework. Oscar Hippolito. Oscar would like to thank his parents who left their home behind to give their son a chance to move ahead. Benjamin Lavsa. Benjamin would like to thank Dr. Carl Nolan for his consistent support and mentorship. Brendan Hodgson. Brendan will be going on a road trip this summer through the western United States before starting his career as a propulsion engineer at SpaceX. Kata Homefelt. Kata would like to thank his mom, dad, Nan, and Gum Gum for always listening and supporting throughout his journey. Jason Huok Tai Huan. Jason proudly reports that after countless rapid unscheduled disassemblies of homework and lab projects, he finally engineered a degree that stayed in one piece. Matthew Eidso. Matthew would like to thank his mom and dad for being the best. He couldn't have done anything without their support. Justin Inman. Justin Inman learned how planes fly. Marco Huili. Marco would like to thank his incredible family and friends, his mentors at Boeing, and Ted Lasso for reminding him that belief and a good sense of humor goes a long way. Senna Keesing. Senna was inspired to pursue aerospace engineering by Apollo 13, Red Mars, and Muppets from Space, which showed her just how wide-ranging a career in space could be. Warren Fisher Lee. Warren would like to thank his parents for supporting him to pursue an aerospace career. Samuel Lank. Samuel Lank would like to thank his mom and dad for supporting him through his education. Kyunyang Lee. Kyunyang would like to thank his family, friends, and professors for their unwavering support and encouragement throughout his academic journey at UW. Oliver Lawrence. Oliver would like to thank his family and friends for the endless love and support he has received. Joshua Lomeli Garcia. Joshua credits this accomplishment to his family and extends gratitude to those who've been there since the early days. What's next? Jarrett Long. Jarrett would like to thank his close friends and family for supporting him through this great achievement. Gabrielle Loop. Gabrielle can fix your computer, but she has plasma homework due tonight, so ask again tomorrow. Carly Brooke Magner. Carly would like to thank her family, professors, and friends for their unwavering support and is grateful for the meaningful experiences and connections made along the way. Alexander Maldonado. Alex would like to thank his mother, his roommates, and everyone who stood by his side through thick and thin over the years. Andrew Matvienko. Andrew would like to thank all his family for traveling to be here today and always supporting him. Osvaldo Monroy. Osvaldo thanks his parents, whose selflessness brought him here. Andrew Moore. Andrew has learned that eye bags go away when you smile. Oh, and he also would like to say, I love you, Mom. Ian Morse. Ian is thankful to have been given the opportunity to attend this college. Natalia Movchan. Natalia would like to thank her academic advisor, Erica Coleman, as well as Natalia's friends and family for the help and support on this journey. Brendan Mullins. Brendan would like to thank his parents for being more supportive than he could ever ask for, and everyone on START for being such a great group to grow with. Aileen Murphy. Aileen will never forget the people who helped her to get where she is today. Not now, not ever. Landon Judd Matthew Norris. Landon thanks his parents and family for their constant support throughout his journey to this point. Their relentless encouragement meant everything, and he will always strive to make them proud. Joshua Ponaskar. Joshua would like to thank his friends and family for their unwavering support. It's their guidance and encouragement that inspired and shaped who he is today. Grace Pardini. Grace would like to thank every person here for being part of her life and helping her become the person she is today. Jonathan Parker. Jonathan would like to thank his parents for always being there for him and for their patience. Celia Perez. Celia is thankful to God for the strength and wisdom that have guided her to this milestone, and she extends heartfelt thanks to her family for their unwavering love and support. Nathan Paredes. Nathan would like to thank their family and friends and gallons of Dr. Pepper in helping him achieve this degree. Vin Pham. Vin Pham is graduating in aeronautical and astronautical engineering and still can't believe herbal tea and group projects actually got him this far. Tong Fan. Tong would like to thank their family, friends, and mentors for their support and encouragement throughout his 4-year journey. Bobby Rogers. Learned it was just as hard 10 years later. Brett David Redman. Brett would like to thank his mom, Debbie, for being his biggest fan and for teaching him to always be the good guy, even if that means finishing last. Hudson Ruckert. Hudson sincerely thanks both of his parents for their unwavering belief in him and constant support throughout his college journey. Davis Ryan. Davis is very grateful for the challenges that have shaped him, the support from his friends and family, and the journey that lies ahead of him. Trail Samarco. Congrats, Trail. Matthew Alexander Salideres. Matthew would like to thank his family for all the support and sacrifices they have made to help achieve this degree, especially his parents, Michael and Maria Salideres. He loves you. Jacob Sawyer. Jacob wants to thank his amazing family and friends for supporting him through ups and downs and making it possible for him to finally walk across the stage today. Ashby Schlitz Brodeen. Ash thanks mom and dad for the love, support, and groceries over the last 4 years. Minor gets a shout out too. Braden Schwartz. Braden was going to write a joke here, but instead he just wants to thank all of the friends he's made in this major. They're ultimately what kept him going to this point, and they deserve to know that. Jonathan Seymour. Jonathan would like to thank his family and friends for the experience of the last 4 years at UW as part of A&A. Jaden Ray Schaefer. Jaden would like to thank his family and friends who supported him greatly through his academic journey. Michael Smith. Michael would like to thank JJ the jet plane for sparking his interest in him when he was 3 years old. Paul Joseph Yang Snyder. Paul would like to give a deep thanks to his friends, faculty, and family for supporting him throughout his journey and making everything possible. Fiona Spitzley. Fiona would like to thank her family for their support. Lachlan Stewart. Lachlan would like to thank his parents for working so hard for so many years and for supporting him in everything from soccer to space. Ilyan Stoyanov. Ilyan has learned that great achievements require perseverance, and he is deeply grateful for the unwavering support of his family, mentors, and friends who made this journey possible. Frederick Felicio Susilo. Frederick Felicio Susilo would like to thank his family, mentors, and friends for their support and inspiration. Ivan Sviridovich. Ivan Sviridovich has discovered that with God's grace, even the most complex orbits align perfectly in his plan. Rohail Tariq. Rohail Tariq first thanks God for his guidance and grace and is deeply grateful to her family, mentors, and friends who helped him turn a childhood dream of flight into a soaring reality. Marcus Valentine. Marcus would like to thank Costco for keeping both his stomach and engineering dreams full. Charlene Valerio. Charlene agradece a sus padres por todo y por mostrarle que todo es posible. Charlene also thanks Miguel and Celine for standing by her through every challenge and success. With the love and support of her family and friends, Charlene walks the stage with pride. Si se puede. Hansen van Lobensels. Hansen would like to thank his family and friends for supporting him. Dina Elise Villaseñor. Dina would like to thank her parents and family for their love and support throughout her academic journey. Lucas Voss. Lucas would like to thank his professors for their guidance, his family for their unconditional support, and his friends for everything in between. Duncan Weiner. Duncan would like to thank his family for their invaluable support. Aaron Wu. Aaron would like to thank his family and friends for supporting him along his academic journey. Love you, Mom and Dad. Shuo Yang. Shuo would like to thank his family, friends, colleagues, professors, CAs, his Spotify playlist, and more for their invaluable support over these last 4 years. Yida Yao. I would like to thank my family and friends for helping me be the best person I can.
Thank you, Professor Herland, and congratulations to all of our exceptional graduates this year. As we conclude today's celebration, I want to acknowledge everyone who made this moment possible. Thank you to our dedicated staff and student volunteers who ensured today ran seamlessly. Big shout out there around the room. Can you stand up? Actually, Betsy, Susan, Paul, Amy, everybody, people in the back. Okay. Thank you to our faculty whose commitment to excellence in teaching and mentoring has shaped these outstanding graduates. Thank you to the families and friends who joined us today. Your unwavering support and encouragement throughout this journey has been essential to our students' success. And thank you to our class of 2025. It has been our honor to guide you, learning, and witness your growth both in the classroom and beyond. As you embark on your aerospace careers, you carry with you not just technical expertise, but the problem-solving skills and innovative thinking that will drive our industry forward. You're prepared to tackle the challenges ahead and to push the boundaries of what's possible in air and space. Go forward with confidence. The aerospace community eagerly awaits your contributions. And now, graduates, please stand. You may now move your tassels from right to left. It is my honor to present the William E. Boeing Department of Aeronautics and Astronautics Class of 2025. We applaud you all. You are now cleared for takeoff.